This video is intended to help you review over the objectives EL1 through EL7, as well as SE1. And so these questions are all from the practice for this objective check. The following problems are for personal review or study purposes only. They will not be graded, so please do not attach work unless you are practicing that function. And as always, I would suggest you do practice that function prior to the actual exam or objective check so that you are familiar with those technical aspects. So let's begin with our first objective, EL1. Evaluate exponential and logarithmic functions in applications including compound interest. Now you may notice that that objective actually consists of lots of things: evaluating exponential functions, evaluating logarithmic functions, and compound interest. As such, there are 3 questions that cover this one objective. So you need to do well on all of these, accomplish all of these well in order to get credit for this one objective. So question 1 says, certain radioactive material decays in such a way that the mass remaining after t years is given by the function m of t equals 305, parentheses, 0.965, close parentheses, to the t power, where m of t is measured in grams. Part A for this question says, find the mass at time t equals 0. Mass at time t equals 0. Well, since t is equal to 0, that means what we are trying to find is m of 0. Evaluating m of t at t equals 0. So this would be 305, parentheses, 0.965 to the 0 power. And putting that into the calculator utility of your choice, we should see that is 305, and so that would be 305 grams. So I'll go ahead and write that in my box, 305, and then again that unit is grams. Right, now part B is how much of the mass remains after 50 years. Well, that means we are going to be finding m of 50 because m of t was t in terms of years. So m of 50 equals 305, parentheses, 0.965, close parentheses, raised to the 50th power. Now this answer will need to be rounded to 2 decimal places. So again, going to my calculator utility of choice, 305 times 0.965, close parentheses, to the 50th power. That is 51 points, I'm going to round this, 51.36. And again, my units would be grams. My answer box, I will write 51.36. Now, as always, the amount of work that I'm showing, I believe, is the appropriate amount of work. And so that should be the amount of work that you click the Add Work button and add to that. Question 2 under Objective EL1 is you deposit $2,000 in an account earning 4% interest compounded monthly. How much will you have in the account in 5 years? This is applying exponential functions to compound interest. Well, I'm going to go and write the compound interest formula here. That is P, or rather A, equals P, parentheses, 1 plus r over n, close parentheses, to the n times t. So all of that is raised to the n times t exponent. Now in this question, the $2,000 being deposited tells us that is P. To identify that as P. 4% is our rate, and that'll be 0.04. Remember, we moved the decimal place 2 places to the left. For that, compounded monthly. Monthly indicates that n will be equal to 12. That's the number of times it's compounded a year. So monthly, there are 12 months. Remember that if you see compounded annually, that means n equals 1. Compounded semi-annually means n is equal to 2. Compounded quarterly means n is equal to 4. And of course, monthly is n equals 12. Now finally, we have how much will you have in the account in 5 years? Well, that is our t. So I'm going to replace all those values into that formula. So this will be A equals 2,000 parentheses 1 plus 0.04 divided by 12, close parentheses, to the 12 times 5. Now some calculators will require you put the 12 times 5, the exponent, in parentheses. So just be aware of that. So 2,000, parentheses 1 plus 0.04 divided by 12, close parentheses, and that is raised to the 12 times 5, or the 60th power. Now this amount is what I have written down on my calculator is 2441.993. Because this is money, okay, we're going to round to 2 decimal places. So the answer I put in my box will be $2,441.99. Now for question 3, the final question of this objective, we're told students in a 5th grade class were given an exam. During the next 2 years, the same students were retested several times. The average score was given by the model f of t equals 87 minus 19 times log of t plus 1 quantity for t between 0 and 24 inclusive, where t is the time in months. Round answers to 1 decimal place. And part A of this says, what is the average score on the original exam? Well, the original exam, when you say that, that means that time is equal to 0. So that indicates we're using t equals 0. So to evaluate that, I'm going to find f of 0, which is 87 minus 19 times log parentheses 0 plus 1 close parentheses. Again, using the utility of your choice, that would be 87. So the average score in the original exam was 87. For part B, it says what's the average score after, or was the average score after 3 months? Well, that means we are going to find f of 3 because t is given in months here. So that'll be f of 3 will be equal to 87 minus 19 times log parentheses 3 plus 1 close parentheses. Now let's put that into calculator utility. 87 minus 19 log 3 plus 1 close parentheses, and that will be equal to 75.56. That's approximately 75.56. So that will round, since we're going to 1 decimal place, to 75.6. All right, so that concludes EL1 for this objective. And now EL2, this objective is graph exponential and logarithmic functions and determine their domain and range. And this question says graph 4 to the x plus 2, that's the exponent, minus 2, and log base 4 of x plus 2 minus 2. So in this setup, we want to choose the type of graph, whether it's exponential or logarithmic, and then graph the asymptote, okay, followed by 2 points. So in the first graph that we have, I'm going to plot the 4 to the x plus 2 minus 2. Now that is an exponential graph, so I'm going to choose the exponential option, which is the increasing graph of the horizontal asymptote. Now, the horizontal asymptote for this function is going to be y equals -2. How we know that is that this function has been shifted down by 2 units. So typically, an exponential function will have a horizontal asymptote of y equals 0. So this one will be y equals -2 because it's been shifted down by 2. So I'm going to go ahead and draw a dashed horizontal line going through -2. And in the graphing tool here, you actually, the first thing it prompts you to do is graph the asymptote. So you actually click anywhere along that line, y equals -2, it'll graph the line for that. And then we need to plot 2 points for it to determine what the exponential graph would be. Now, you can use a graphing utility and look at a table. You can evaluate by plugging just in some x values. And let's see what we can graph here. So I'm going to pull up my graphing calculator and then look for some perfect points. Okay. There appears to be an x-intercept. That's not at a perfect point. But then we have this point right here. There's the point -2, -1. So that's one that I would plot. And then it appears that we have another good point at -1, 2. And then the tool here will determine the rest of that exponential function from that. Now, what I'm actually drawing here is a sketch. It'll be a lot more accurate with a computer or a graphing calculator. All right, now the second equation we want to graph is log base 4 of x plus 2 minus 2. Now, so we're going to first select, let me circle on the first one. I'm going to circle the logarithm tool. It has an increasing graph, but it has a vertical asymptote. So first we want to graph the vertical asymptote, which is going to be at x equals -2. X equals -2. I know that because x plus 2 will be 0 whenever x is equal to -2. So I'm going to go ahead and choose that. And of course, it will be graphed for you once you click x equals -2. Now, 2 points that we might choose. And I'm actually going to choose 2 very particular points. I'm going to choose x equals, so let's see, my x equals -1, because -1 plus 2, thinking about the argument of my logarithm, -1 plus 2 would be 1, and we know that what the log of 1 is. Okay, so that would be a really good, I know there's going to be a good point at x equals -1. There will also be another good point at x equals 2, because 2 plus 2 would be 4, and when it's a base 4, so when those two things, the argument and the base match, that's going to be a good point. Now, if I go ahead and take a calculator and I do type in just some values, do some calculation to get what that point would be. So I'm going to have log base 4. Log base 4 of -1 plus -1 plus 2, close parentheses, minus 2. That is a value of -2. So that means since I plugged in -1, got out -2, that would be the point -1, -2. Okay, and now similarly, I will change that to be x equals 4. So log base 4, log base 4 of 2 plus 2 minus 2. That is a value of -1. So I have the point 2, -1. And again, this technological tool will then plot the rest of that logarithmic function. Now, it might be a good idea to add work to something like this. However, there really isn't much to be added. However, it's a good idea, really, to have a picture of what you're thinking, at least. Scratchwork sort of things. That tells me what you're thinking. So when I'm determining, do they know how to do this skill or not, that's what I'm basing that off of. All right, now the last part of EL2 is find the domain and range of a function, a logarithmic function. Find the domain and range of y equals log base 6, parentheses, 7 minus 3x, close parentheses. So to find the domain of a logarithmic function, I'm going to take the argument, in this case the 7 minus 3x, and set that greater than 0. Now I need to solve this and then determine the interval that's going to represent. So 7 minus 3x is greater than 0, so I will subtract 7, which means negative 3x is greater than negative 7. Dividing by negative 3. On both sides we see that x is less than, and that will be a positive 7 over 3. Now it's less than because when we divide by a negative or multiply by a negative, the sign, the inequality sign switches. Now the interval that would represent x is less than 7 over 3 would be the interval parentheses minus infinity, comma, 7 over 3, close parentheses. Now, the range of a logarithmic function is always minus infinity, so parentheses minus infinity, comma, infinity, close parentheses. And again, the work that we just showed for finding the domain would be good work to include and attach to this question. Now that concludes EL2. Remember, some of these are very big topics, so that's why there are several questions to work with. Now EL3 consists of one question: convert between exponential and logarithmic forms. So this question says, if log base 5 of the quantity 5x plus 2 equals 1, then x equals what? Well, we're going to use the idea that we can convert between logarithmic forms and exponential forms to solve for x. So log base 5 of 5x plus 2 equals 1 means that 5 to the first power, the base to the power of the other side of the equal sign, is equal to the argument, in this case 5x plus 2. So 5 to the first power equals 5x plus 2. Now 5 to the first power is just 5, so we have the equation 5 equals 5x plus 2. So we'll solve this by subtracting 2 from both sides. So 5 minus 2 is 3, so 3 equals 5x. Dividing by 5, we see that x is equal to 3/5. And that is what we were trying to find. X is equal to 3/5. And of course, that work backs this up. All right, EL4, as an objective, says expand or condense logarithmic expressions using properties of logarithms. And question 7 says, use the product, quotient, and power properties of logarithms to expand the following. Assume all variables are positive. We have log base 3 of, and then in parentheses, we have a quotient. Numerator is 14p to the 6th, and the denominator is y to the 16. So we're expanding this because we're starting with one logarithmic expression. We're going to end up with several logs. Now, remember we have the product rule, which means that things that are multiplied inside of a log can be split into two logs as addition. We have the quotient rule, which says two things that are divided inside of a logarithm can be written as subtraction of two different logarithms. And then finally we have the power property, which says that if we have an exponent inside of a logarithm, that can be written as the coefficient of a logarithm. So we can bring exponents down, can split addition or multiplication into addition, can take division and turn that into subtraction. Now I'm going to use this, put together with all of the things we've talked about in our notes, to go ahead and just jump to the answer, okay? Log base 3 of, again, 14p to the 6th all over y to the 16 will be equal to log base 3 of 14 plus 6 log base 3 of p minus 16 log base 3 of y. The division became a subtraction, hence the minus 16 log base 3 of y. The multiplication became addition, hence the log base 3 of 14 plus, and then we have the log base 3 of p, and then the exponents were pulled down, so we have a 6 log base 3 of p minus 16 log base 3 of y. So again, that full answer is log base 3 of 14 plus 6 log base 3 of p minus 16 log base 3 of y. Now those same properties can be used in reverse to condense or combine things into a single logarithm. So this next question, question 8, says write the following as a single logarithm. Assume all variables are positive. Log base 4 of 5 plus 7 log base 4 of y minus log base 4 of 7. Very first thing is I'd write 7 log base 4 of y as log base 4 of y to the 7. I'm just going to write that underneath that. Log base 4 of y to the 7. And then we have at the beginning of that log base 4 of 5. And at the end, log base 4 of 7. The addition will become multiplication. So this will be log base 4. Log base 4. And in parentheses, I'm going to have 5y to the 7. But then I'm going to have division by 7. So the answer is log base 4 of 5y to the 7 over 7. Now, there's a note here, a hint that says the answer format in lowercase letters is log underscore base. Parentheses, number, close parentheses. Remember, that's how you want to get a base, is use an underscore. All right, EL4 or EL5. This, as an objective, says solve exponential equations. Now, there's a hint here, even in the instructions. That is, it says we're going to solve exponential equations with like bases and with logarithms. The first question will definitely use like bases. The second equation will definitely use logarithms. Keep that in mind. So question 9 is going to be solving with like bases. And it says, solve for m. 6 to the 5m minus 2 is equal to 1 over 1,296. Now, because we know we're using like bases here, very first question might be, well, what power of 6 is 1,296? Because we want to write both of them with the same base. So I might go, let's see, 6 squared is 36. That's not right. 6 cubed is 216. 6 to the 4th is 1296. All right. So 6 to the 4th equals 1296, which means 6 to the negative 4 is equal to 1 over 1296. Now remember, there is another thought process with some of these questions where you might have to write both sides of the equation using different, or use the same base, but writing both sides using that. So you might want to refer to the notes in case you run into something like that. But we know that 6 to the negative 4 is equal to 1 over 1296. That means that 6 to the 5m minus 2 equals 6 to the negative 4. Because we have the same base, we know that the exponents must be equal. So 5m minus 2 equals negative 4. Solve that by adding 2 to both sides. That means 5m equals negative 2. Negative 4 plus 2 is negative 2. And then dividing by 5 on both sides means that m equals negative 2/5. And so that is the answer that goes in my box. And of course, I now have a sufficient amount of work to add to that question. Now, this objective includes solving with like bases and with logarithms. So this next question, we will need to use logarithms. Question 10 says, solve for x in the equation below using logarithms. Round answer to 3 decimal places. This equation is negative 6 times 10 to the x minus 1 equals negative 4,717. The very first thing I want to do is try to isolate the 10 to the x part of this, the exponential part of this. That was going to require me to add 1 to both sides first. My resulting equation is negative 6 times 10 to the x equals negative 4,716. Now I can divide both sides by negative 6 to isolate the 10 to the x. So So that 10 to the x is equal to, let's see, 4,716 divided by 6 is 786. So 10 to the x equals 786. Now, to remove the base of 10 there, I want to use a logarithm. That's the only way to get an exponent out, when x is an exponent. However, because we have a base of 10, a 10 to the x, the wise choice would be to use a log base 10. So I'm going to take a log base 10 of both sides. Log base 10 of 10 to the x equals log base 10 of 786. On the left-hand side, that means we're just left with x. So x equals log of 786. You don't actually have to remember the base 10. It's there. You could just write log. That's what I'm doing. All right, now log of 786. Log of 786 is equal to approximately 2.8954. But we're rounding to 3 decimal places, so we would say that x is equal to 2.895. And as always, we have some work to go to add to that question. The next objective, we have EL6. Solve logarithmic equations using properties and the one-to-one property. So question 11, our one question for this objective, is solve ln of x plus ln of x minus 1, that's a quantity, equals ln of 42. We're going to first use our product rule on the left-hand side to combine ln of x plus ln of x minus 1. That will be ln of x times x minus 1 quantity. And that equals natural log of 42. Now, because of the one-to-one property, so we've used the product rule for 1, but the one-to-one property says that x times x parentheses x minus 1 close parentheses must be equal to 42. All right, so I'm going to distribute the x there, so that will be x squared minus x equals 42. Let's move the 42 to the other side by subtraction, so that'll be x squared minus x minus 42 equals 0. I want to get those on the same side because this is a quadratic. I want to see if it'll factor, so two numbers that multiply to be negative 42, but add to be negative 1. That would be 6 and a 7, let's see, a positive 6 and a negative 7. So this will factor as parentheses, x plus 6, close parentheses, open parentheses, x minus 7, close parentheses, equals 0. Now setting each one of those factors equal to 0 tells us that x is equal to negative 6, or x is equal to positive 7. Now let's go back to our original equation. Notice that each one of these natural logs has an argument. Now one of them is natural log of 42, don't worry about that one. But natural log of x implies that x must be greater than 0. So our solution must be greater than 0. Now the next one is natural log of x minus 1. Now x minus 1 being greater than 0 implies that x must be greater than 1. So any solution we have to this equation must be greater than 0 and greater than 1. Well, that causes us to eliminate negative 6 as a possible solution. So x equals 7 is the correct answer. Now, in the question, it actually says reject any extraneous solutions. The negative 6 was an extraneous solution. All right, our next objective is EL7. That objective is solve applications with exponential and logarithmic equations, specifically with doubling time. So this question is a doubling time question. It says you deposit $2,200 in an account earning 2% interest compounded monthly. How long will it take this investment to double? Round your answer to 2 decimal places. Use this compound interest formula. A equals P parentheses 1 plus R over N close parentheses, to the n times t exponent. All right, so we want to first note the amount that's being deposited is p. That's p equals 2200. Our future value, a, is equal to that investment being doubled. So multiplying 2200 by 2, I'll write that 2 times 2200 would be equal to 4400. So that is our a value. We know that we have 2% interest, so our rate, is 0.02, converting that to a decimal. And we also can see that it's compounded monthly, which means n is equal to 12. Now time, t, is a question because we are trying to find that. How long will it take for this to double? So let's go ahead and fill in the information we know. It gives us this equation. We have 4400 equals 2200, parentheses, 1 plus 0.02 divided by 12 raised to the power, close parentheses, raised to the power of 12 multiplied by t for time. Let's do a little bit of work to clean this up. First, we can actually divide both sides by 2200. So dividing 4400 by 2200, that is 2. So 2 equals, and I also would really like to combine that together if I could. Let's see, in the parentheses we have 1 plus 0.02 divided by 12. That is a nasty decimal, but I'm going to make it a fraction. Ooh, that's not so great either. Seems that should be a nicer fraction than that. Let's see. I guess that could work. So let's see, that'd be... Actually, I'm just going to go ahead and leave that then. I'm going to leave that. I don't want to round anything. So this gives me the equation 2 equals, parentheses, 1 plus 0.02 divided by 12 raised to the 12t. It's 12 times t. The only way we can get exponents out is by taking a log of some sort. So in this particular instance, I'm going to take the natural log. So I'm going to take the ln of both sides. This allows us to use the power rule and to write this equation as ln of 2 equals 12t ln parentheses 1 plus 0.02 over 12, close parentheses. Now this is a messy looking answer, but I can solve for t very quickly by dividing both sides of this equation by this quantity, 12 ln parentheses 1 plus 0.02 over 12. 12 ln parentheses 1 plus 0.02 over 12, close parentheses, on both sides. So this results in t is equal to, big fraction here, my numerator is ln of 2, my denominator is 12 ln parentheses 1 plus 0.02 over 12, close parentheses. Now that is my exact form. My exact answer is that. But this question wants to know about how many years that is. So it might make more sense to give it in a rounded form. So let's say natural log of 2, close parentheses, divided by 12 natural log 1 plus 0.02 divided by 12. And close parentheses. All right, so that is approximately 34.6. They must have around 2 decimal places. So that would be 34.686, which will round to 34.69 years. Now, the thing to watch out for is if your question doesn't say monthly, obviously this wouldn't quite work because N would be something different. Remember, semi-annually means 2, quarterly means 4, annually means 1 for N, and monthly means 12. All right, the very last question we have in this objective check, or set of objectives, is SE1, that is solving equations, systems of equations. This objective says, SE1, use augmented matrices and reduced row echelon form to find a solution to a system of linear equations. So in question 13, we have use an augmented matrix to find the solution to the system of equations, or of the system of equations. And here's our system of equations. I'll read it out loud. X plus 5y plus 6z equals negative 2. That's equation 1. Equation 2, 5x plus 3y minus z equals 13. Third equation, negative 5x minus 3y plus 2z equals negative 18. And we want to know what x, y, and z are. Now, you may already see the matrix that I have entered into a calculator utility. It is the matrix 1, and then reading my first row, 1, next entry 5, next entry 6, and next entry negative 2. Those are all coming from the coefficients and the constant of that first equation. Now the second row of my matrix is 5, next entry 3, next entry negative 1, next entry 13, coming from the second equation. And my final row is negative 5, next entry negative 3, next entry 2, next entry negative 18, all coming from those equations that we have, the coefficients and the constant equation. And I'm just checking that very quickly. Okay, good. Those are all correct, because if we type this incorrectly into a calculator, this isn't going to work. Now, once we have that matrix saved, we'll perform what is called reduced row echelon form, RREF, that operation on this matrix. And I've actually done this already and have a picture of my work here. So doing RREF, I produce the matrix. And the first row is 1, next entry 0, next entry 0, next entry negative 2. Second row, 0, next entry 1, next entry 0, next entry 6. Third row, 0, next entry 0, next entry 1, next entry negative 2. Now, because we have what is called the identity matrix, the 1, 0, 0, 0, 1, 0, 0, 0, 1, as a big part of our matrix, the final column tells us the values of x, y, and z. My final column was negative 2, and then 6, then negative 5. So x is equal to negative 2, y is equal to 6, and z is equal to negative 5. Now, there are two skills involved here. One is writing the augmented matrix, the matrix A that I have here. And then the second is actually knowing to use the reduced row echelon form. So again, be aware of that as you prepare for this objective check, for this exam. Hopefully this will put you in the right direction. Good luck.